Well, good morning, everybody, and welcome to NASA's Johnson Space Center here in Houston for today's status for Discovery's preparations for launch on the STS-133 mission. Joining our briefers today here in Houston, we have John Shannon, who's the Space Shuttle Program Manager, and Mike Suffredini, who is the International Space Station Program Manager. But we'll start our briefing today with comments from the Associate Administrator for Space Operations, Bill Gerstenmaier. He's actually located at NASA headquarters in Washington, D.C. So we'll start up there with comments, and then we'll come back here for comments and then take questions. So with that, I'll toss it to Bill up in Washington.
All right. Thank you, Kyle. Again, it's our pleasure to talk to you today. Like we've talked about before, is we want to kind of give you a continuous status and continuous briefing of what the work is going on with STS-133 as we're progressing towards eventually getting that flight ready to go fly. John and Mike will talk to you some more in details about what's going on. And John had a very detailed meeting yesterday with the PRCB. He'll give you some details of that. Basically, the teams have made very good progress so far. They've done a lot of good analysis. They've done a lot of good forensics, looking at the actual stringers that were cracked on the tank and those activities. So they've done a very, very thorough job of looking at the data at hand and ready to move forward. But I think we've kind of come to a point in the investigation where we need to do something a little bit different. It doesn't look like just pure analysis, and the data at hand is going to reveal what really occurred on this tank out on the launch pad and what will ultimately lead to flight rationale for us for the flight. So I think it's time that the teams have recommended we step back a little bit and do some testing. John will talk to you a little bit more in detail about the testing, but there's basically two things that we would like to go do from a test standpoint. We'd like to see if we can replicate what we think the most leading cause is of the failure. So there'll be a setup at Marshall or New Orleans where we'll actually build up a stringer panel the way we would have for a tank. Then we'll actually put some defects in, some edge of manufacturing tolerances into that device, and then actually load it up and see if we can replicate the crack that we saw during cryo-loading during the tanking. So that will be one test that will get done. And then we'd also like to do a test down at the Cape where we actually load the tank with cryogenic propellant and then actually put some instrumentation on the tank, put some strain gauges, thermocouples, some other devices on the tank to actually monitor how the tank actually loads up. And that will serve to validate the math models and help us to better understand the environment that we see during loading and how that relates to the environment we see during launch. So we'll kind of approach it two ways. First of all, understand what could have caused the crack from a kind of a root cause standpoint. Instead of just looking at the data at hand, we'll actually do two tests to do that. One, we'll look at the loading of the panel itself and the manufacturing defects. The other test will look at the loading conditions actually on the tank out at the pad. So we think between those two tests, we should get enough information that we can actually move forward and head in the right direction. So when we laid in those tests just kind of conceptually, there's really no way we can get there before the December launch window. So what we'd like to do now is just kind of take that off the table, let John and his team do a little bit of planning over the next several days, first part of next week, and analyze the overall test plan and the workflow between now as we go forward. So we're kind of setting the next launch date just tentatively around February 3rd. We'll again let John's schedule and the work kind of flow out to see if that all can fit in. The first look is it looks like it fits before February 3rd, but before we pass judgment on that, we'll let John and his team actually analyze the work ahead and figure out the right thing to go do. So again, I think the teams have done a tremendous job of doing the work. It's time to pursue a different path, and that's to head out with some test data. I have a quote or kind of paraphrase from Hugh Dryden, who used to do tests for NASA, and it says, you know, the purpose of tests is to separate real from imagined problems and to reveal overlooked and unexpected problems. So basically what we're going to do with these tests is we're going to make sure we didn't overlook anything. We'll see if these tests can reveal any new information for us, and it'll also help us sort out what the real problems are that we need to be working on versus ones that we just think theoretically may be there. So these tests stand to really move us forward. We're at that point in the troubleshooting where we need to go add these additional tests. We'll take the time to do that, and we'll get ready to go fly when it's time to go fly. So with that, I'll turn it over to John and to Mike down in Houston, and they'll give you some more details on the plans, and then we'll be ready to answer your questions. So, John?
Okay, thanks a lot, Bill. And that was a good overview of where we are. You know, we got into the technical meeting yesterday, our Program Requirements Control Board, the PRCB. And the team has been making very significant progress along the plan that we had laid out. And if you remember when I talked to you before and when this problem first occurred, we were expecting to find an obvious problem, some kind of a flaw in the material, some kind of a crack that had been missed during the construction of the inner tank area. And as we have gone through the investigation, we're not finding that obvious flaw or that obvious problem. We're going through a very rigorous fault tree methodology where you lay out all the potential factors that could cause this, and then through test or analysis work through them and either leave them on the fault tree as potential contributors or take them off if appropriate. The team has done a lot of things in that fault tree investigation, like we have done our fracture analysis where you actually look at the crack surface, and it showed to a little bit of our surprise that there was no initial crack in the stringer that was exacerbated during the bending effects of loading the cryo into the tank. So that was a little bit of a surprise to us. We've also finished our initial look at the loads that that stringer area would see when we put liquid oxygen into the tank, and we think we understand that. We've compared that to the design, and the design looks very robust. It does not look like it should be susceptible to having a crack if it is assembled properly when the initial loading occurs on the launch pad. We've looked at the material from that stringer, and the material is right down the middle for hardness, for tensile strength, for all the different parameters that we would look at to see if it had a problem. So what has happened is we've hit a point where there is no obvious answer as to what occurred. And what that means is that we have to take the next step. And we have to look in greater detail to understand what types of stresses you could put in these stringers during the assembly process, see how they could line up and add stress to that stringer. And we have to do that through a demonstration. Analysis is not going to get us there. Bill quoted some test philosophy. You know, we got last week the famous quote that, you know, one good test is equal to 1,000 expert opinions, right? And so we're at the point where we need that test. We need that fine level of data and to understand exactly how those assembly stresses could line up to give us a crack when we initially load it. And that's one side of it, is to understand how we could have pre-stressed the part. The other piece of it is we really need to understand what the loading environment does to that stringer. We need to understand to a very fine level exactly how much stress is put in that part at loading, because if we're going to have an assembly condition that adds stress to it, well, we need to know exactly what cryoloading stress there is to determine if that is really a feasible root cause for what happened on the STS-133 tank. And it's like Bill said, analysis can only get you so far, and it's time to go test. And that was the recommendation to Bill and the senior leadership, is that I need to better understand the conditions so that I can understand my root cause. From that root cause, I can determine if I have an adequate screening capability to verify that I don't have this problem anywhere else. And those two tests are going to give me that data that I need. We'll assemble it. We'll introduce flaws in the assembly that we think are reasonable that could have happened at the plant. We'll understand through the instrumented tanking test exactly what level of stress we're putting on that stringer. We'll add those two together and see if we could have had the fracture of the part. Now, the tanking test we've been talking about for a little over a week. We had considered just doing a tanking test with no instrumentation on it. Basically, you would load it up like you would for flight. We would go out afterwards and X-ray the repaired area and the other stringers and see if they did as expected during the tanking test. That's a little bit too gross of a test. It doesn't give us the fine level of detail that we need. So we're in discussions today, tomorrow, Sunday. I believe like on Monday or Tuesday we'll have a really good plan for where we want to put instrumentation. And the instrumentation is along 3 different paths. The first is strain gauges to directly measure the stress in the particular part. And we'll put strain gauges on the inside and outside of the repaired stringers, of stringers that have not been repaired, and then some stringers that are just off to the side to make sure that there's nothing in this localized area that is having an issue. So we'll have strain gauges, we'll have thermocouples, because understanding the thermal environment and the boundary conditions on this structure is critical to understanding the stress level in it. So we will put thermocouples in there that will give us temperature readings throughout the entire loading condition. And the last one is an optical assessment. We're going to have cameras, basically stereo vision cameras, looking at the tank, and we're going to put markings on the tank so that we can understand 2 things. One is the tank shrinkage that you get from the cryo. It shrinks about a ½ inch radially, but we need to understand that even better. And it also, as you load up the LOX tank and it fills up, you get a slight rotational component on the flange connecting to the inner tank. So we're hoping that the optical piece plus the strain gauge measurement will give us a really great indication of what the stress level is in those stringers. And then that gives you the baseline stress. We believe the design is robust and should not fracture under that stress. We'll verify that, and then we'll add the assembly issues that you could potentially have to see if we can get to a root cause. We were hopeful early on that it would be some very obvious kind of flaw. Didn't happen. Then we were hopeful that just a simple cryo tanking would cover us for any ascent loads. It's very close, but it's not quite there. So now we have to go to that next level and really understand this problem to get the root cause and determine what our screening criteria is to fly that tank confidently. So that's the next step we're marching down. It's unfortunate that we're not making the December launch window. I think, as Mike will tell you, we have good program plans to overcome that. We want to make sure, though, that we do this exactly right and step along the path. And as we learn more about the different conditions, then we'll make decisions as to where we go from there. So that's our current status. And I think Mike was going to tell you about the impacts that whole plan will have on the ISS program.
So good morning. Before we get into a discussion about having 133 in the early February timeframe, I'll talk a little bit about near-term activities on board ISS. As you know, our SpaceX friends are out there planning a hot fire test today. So we're looking forward to that. This particular flight is what we refer to as Demo 1. It's one of 3 demonstration flights that will occur over the next year before the first actual cargo flight flies to ISS towards the end of 2011. So that's very important to us as a program. In addition to that, on the 20th of December, we're going to do a test with the Special Purpose Dexterous Manipulator on orbit. This test is in order to prepare ourselves for the removal of a couple of ORUs that are flying up on HTV-2. We're actually going to move a couple of what we refer to as CTCs, or large boxes outside that hold multiple smaller ORUs, orbital replacement units. So that's a very important test for us, just to exercise the system and make sure we're prepared for the HTV flight that will dock on January 27th. Of course, before that occurs, we have the crew, the next crew coming to orbit. The 25 Soyuz crew of Katie Coleman, Dmitry Kondratev, and Paolo Nespoli. They actually landed in Baikonur today, and they're doing their preparations for a 15th of December launch. And then once they get to orbit, the plan is to go ahead and do this SPDM test that I talked about earlier. So all of those plans are in work. We've modified the crew time since we don't have 133 there. We've pulled up some of the work. We have taken a couple of steps in preparation for STS-133. One was to remove a Cedra bed, which we plan to return on 133. So it's been removed. That work is behind us now. So let's talk a little bit about 133 in the February timeframe. There's a number of things you look at with any flight when it moves around. One is, of course, the items on board and how it may or may not affect your ability to do operations, either from a logistics standpoint or if you had planned operations that required an item that was coming up. The other is how does it fit in the vehicle traffic, which we work very hard these days to try to squeeze things in when there's holes, as opposed to just having one flight slip and then everybody slip to the right. That's a much more challenging way to do business, and we try not to operate that way. And then the last, of course, is the impact to the timeline on orbit. This particular flight, although very heavily loaded with supplies for ISS, does not have that much in the way of day-to-day consumables. Most of our food for the near term is flying up on the HTV and the ATVs that are flying up here early part of next year. And the remainder consumables, other than those for the urine processing assembly, are coming up on other vehicles as well. So we're in really good shape consumable-wise. As I mentioned earlier, the tanks in the urine processor that collects the brine over time that we have to replace and bring home and empty and bring back to orbit. We're down to our last tank on orbit. We're operating in a slower mode that primarily is its purpose is to utilize the UPA on a semi-regular basis in order to keep the system working, as opposed to the level that we would do to process all the urine that is produced by the crew members on board. This extends the life of the UPA, and of course the downside of that, of course, causes us not to produce as much water on orbit, which is not a problem for us. We have quite a bit of water on board. But it also consumes yedeves, which are the tanks that we put urine in if we're not processing it. And so we're managing those consumables very closely. STS-133 had the advantage of bringing up 5 of these RFTAs, or they're large tanks, and so we would look forward to those coming up. However, both the HTV that's coming up in January and the ATV coming up in February both have RFTAs as well. So from that respect, from a logistics standpoint, we're in good shape. From a vehicle traffic standpoint, the February 3rd date is actually chosen because it fits inside the traffic pattern, if you will. HTV docks on the 27th of January, and then the 41 Progress vehicle arrives on the 31st of January. We do have to do some maneuvers with the HTV. With this new plan, because it berths to the nadir port, we can't have a vehicle on the nadir port of Node 2 when the shuttle arrives. And so we have a plan to maneuver it to the zenith port to get it out of the way before the shuttle arrives, and that will be completed by February 2nd, and then that's what opens up the window for the shuttle to come dock on February 3rd. We have a little analysis to do to be able to do that maneuver, but it's well within our capability, and that is in fact probably the biggest change in our plan with the 133 flying in this time frame. Before, the plan was to have 133 come up, and it was going to we were going to rearrange the stowage with the PMM on orbit. And in addition to that, it brings up a pallet. And this pallet has the locations where the ORUs that are coming up on the HTV were going to be put. So we have this relationship between now the HTV and the shuttle, and we need to make sure that the HTV is there at least during the period of time when the shuttle's there, so we can remove the ORUs out of the HTV, the large external ORUs out of the HTV, and install them in the pallet that the shuttle will bring up. So in order to ensure that we have that capability, we're extending the on-orbit dock time of the HTV for 60 days to ensure that we cover both the early and late February windows for our shuttle shuttle flight, and that'll just protect our ability to get the ORUs out of the HTV and installed on their proper pallet that the shuttle is bringing up on 133. So from a vehicle traffic standpoint, the big change for us is HTV will dock at the Nader port, and by the 2nd of February, we will have moved it to the Zenith port. Before we move it to the Zenith port, we'll pull out the external pallet and attach it to the gym exposed facility that's at the end of the gym module, and then that pallet will stay out there until the shuttle arrives, and we move the ELC from the payload bay of the shuttle to the ISS. Then when ISS departs, we'll do the robotic maneuvers to put those 2 ORUs that are on the pallet that came from the HTV onto the pallets that the shuttle brought to ISS. And then we'll move HTV back to the Nader port, reinstall that pallet, and then send it on its way. So that's the biggest change that flying in early February does to us. The rest of the flights, we've left them where they were and put the shuttle in between, and so that's worked out very well for us. From a crew time standpoint, it's just our day-to-day life is change, and we've accommodated this. Like I said, we've gotten some of the tasks we planned to do actually during the shuttle flight 133 have already been accomplished by the crew on orbit, and meanwhile we're moving activities up that we would have otherwise had to postpone because the shuttle was there. So we're jockeying around the work of the crew on orbit in order to accommodate this move, and that's relatively standard for us. Every day brings a new opportunity for us to replan the crew's day, and this is no different. So from a station standpoint, we're in good shape with this move, and we can support whenever our shuttle colleagues are ready to go fly.
Okay, thanks, gentlemen. Due to our unique configuration, if you would, when the microphone gets to you, address your question to the appropriate individual. And I've got a lot of people in about a half an hour to support question and answer. So if you would, try to keep your question brief. And we'll start right here with Mark.
Oh, thank you very much, Mark Carreau for Aviation Week and Space Technology. In your comments today, I think it's for John Shannon or Bill Gerstenmaier. In your comments today and those last week, it sounded like you really are looking for an assembly, manufacturing, or transport, some sort of issue that's related to the movement or handling or assembly of the tank, rather than a design problem. And I'm just wondering if in the tests that you do, if there was some design issue, would that emerge as well? As your testing intended to address that, or would it just encompass that if that turned out to be the case?
Yeah, I'll take that. We understand the design very well. What we're trying to clarify is the loads that are imparted on that design during initial cryo loading. So our current belief is the design is robust and capable of handling those loads, but when we do the tanking test and really understand what those loads are, we may revise that opinion. So we'll see if we're a little bit closer to our failure criteria. And what you said previously about we're starting to home in on an assembly issue, that's one of several different possibilities coming out of the fault tree. We'll just rigorously work through that, and we'll do testing where appropriate to understand that further.
Robert.
Robert Perlman with collectspace.com with a question for John Shannon. Can you just give us an overview of how this affects the manifest looking further down? What's the window for the February 3rd attempt? Do you still have that window at the end of the month as well? And then what does it do for STS-134 and if you got approved STS-135? Right. Robert, the windows that we're looking at, as Suf had said, is February 3rd through February 10th is the first one, and our current testing and analysis we believe will support that window. Of course, there are decision points based on what we learn out of our testing to determine if we'll make that, but right now that's our next available window. The February 27th window is still good. It's the 27th through March 6th, I believe, yeah. And then we have 3 windows in April with a couple small beta violation cutouts. And then May, June, July, you all have launch opportunities in there. So, what we have kind of mentally laid out so that we can prepare the
the teams that work on Endeavour and Atlantis is we expect to be in a position to launch Discovery sometime in February. That will provide an opportunity to launch 134 in April. And then we believe that if we fly an STS-135 mission, that June is still a real possibility for that, or there are other options, down later in the summer. So, right now we're really focused on Discovery, but we still have to kind of lift our head up and make sure that we're still protecting the milestones to meet further launch dates. So I'm thinking February, April, and then sometime in the summer is reasonable. Mike, did you have any addition to that?
I covered it.
Eric Berger with, excuse me, with the Houston Chronicle. Kind of following up on that question from Mike Suffredini. Given the fact that now a 134 may go up in April or even a bit later, does that diminish some of the need for 135, or would there still be a need from the station standpoint to fly that mission, even though it sort of would come closer to 134?
Yeah, the need for 135 is not based on when the shuttle flies. It's based on the mass to orbit, and so 133 and 134 are full, and we have a manifest that we've planned for 135, which fills an MPLM, so that we would lose that up mass, and that's the up mass we'd like to have in order to protect any slips in the commercial cargo flights coming up.
Okay, let's go down to the Kennedy Space Center in Florida for a couple of questions, please.
Marcia Dunn, Associated Press, probably for John Shannon. Could you envision not ever being able to find root cause, and if that were to be so, would you fly 133 anyway at that point, or would you be recommending not to fly another shuttle flight?
No, I have strong confidence, Marcia, that this is a solvable problem. It is a little more subtle than we had initially believed it would be. I think through the testing plan that we have laid out that we're going to determine root cause. Then we'll have the discussion on what type of screens we have to protect for that root cause failure. So that's the plan we have laid out, and I don't see us deviating from that.
Bill Harwood, CBS News, with one for John Shannon. Actually, it's one, but maybe a couple of parts. On an instrumented fueling test, do you have a rough time frame for that? And I'm wondering, at the pad, I'm assuming to install this sensor, as you're talking about cutting foam away, at least on the outside, to put it in. You've got cabling issues and all of that. I'm just wondering if you could maybe just address the complexity of an instrumented fueling test at the pad. Thanks.
Yes, good question. As for time frame, we are going to have the requirements defined by the middle of next week so that everybody agrees that, yes, this is the data that we need from the tank. My goal is to do this in late December timeframe. I would like to very much do it in December. It is very complicated because you roll the rotating surface structure away from the stack when you fuel it. And that's for things like Firex and Viz and just a lot of safety issues associated with the vehicle. So what that means is that you've got to find a way to get the cabling from the inner tank region to the fixed support structure. And there's several ways to do that. You can hang cables down to the orbiter access arm. You can go up and go across the OAA, the GOX vent line. You've got the GUP, which we all know quite well. And so there's some ways to get it back to the fixed service structure. The plan right now is that I want to do a test in a flight configuration. So what that means is that we would remove foam, that nice foam that they just put on the tank, right? We would go remove that. We would put our instrumentation on there, and then we're going to foam it back up because I want the most accurate models that I can possibly get of the stress and the temperature in that area in a flight configuration. So that takes time, and that's what has kind of driven us out of the December window to get the fidelity of the test that we desire. It's foam removal, it's instrumentation placement, it's you put the foam back on, it looks like the vehicle is ready to go fly, except for the wires coming out of it, and we collect all that data in as high a fidelity test as we possibly can. And we still have the discussion on do you go to a complete different area of the LOX center tank flange to capture more data, or do you stay in the area that we saw this problem in? We're having discussions on the liquid hydrogen flange to see if that's something we want to instrument to gain more knowledge there as well. So it's all that discussion will take place over the weekend and early next week. We'll have the requirements set by the middle of next week, and then we'll have the schedule laid out for the test, and our goal is to do it in December.
Okay, let's go to the phone bridge. I'll call on you in the order that you called into the newsroom. First up, Andrew Cox.
I don't have a question right now, thank you.
Okay, thanks. Gina Sinceri, are you out there, Gina? How about Peter Spots with Christian Science Monitor?
Yeah, thanks a lot. This I may be misremembering, but I thought in a prior briefing there was some discussion about perhaps if the launch had to be delayed until February, that might affect the amount of mass you can take up. If I'm remembering that correctly, I wonder if you could unpack that a little bit, and if I'm not remembering it correctly, let me know that too.
From a shuttle standpoint, there's a performance penalty for launching in February that has to do with the temperature and the booster propellant and how cool it gets. There's also some atmospheric effects of that. That is about 300 or so pounds, and Mike has a plan. So.
Well, actually, we don't have to go into the PMM. The shuttle guys have worked with us very closely. There is a performance penalty. We make it up largely by removing ballast that we don't require in the shuttle, actually. And so we have, at one point, you do remember correctly, at one point we thought we might have to get the PMM out and load some of the items in the mid-deck into the PMM to be able to take it to orbit. But the team has worked that very hard together over the last week or so, and we've determined that it won't be necessary to get into the PMM. We've taken one or two very small items off out of the mid-deck, and those items are being shipped to French Guiana. Will fly up as part of the late load on ATV. But that's less than 100 pounds worth of items, so it's a very small impact. But other than that, that was the only change we had to make in order to meet these windows.
Okay, thanks. Thanks, Peter. Let's see, Denise Chow, space.com.
Hi, it sounds like the instrumentation tests and all that can be done with the shuttle at the pad. This is a question for John Shannon. Do you anticipate at all having to roll back?
Yeah, there's no data right now that's driving us to roll back to the VAB. The only thing we've thought about is it gives you access to the back side of the tank. So if we had a condition where we felt it was important to X-ray the stringers on the back side of the tank away from the orbiter, then we would do that to gain access. But right now, that's not part of the plan.
Okay, let's see. Carrie Sheridan, are you out there with AFP?
I am, but I don't have any questions at this time. Thank you.
Okay, thanks. Ken Kramer, Spaceflight Magazine. You there, Ken?
Hi, thank you. Yeah, actually, my question was also about the rollback. If you did have to roll it back, however, what would be the consequence of that? And do you have any consideration of possibly switching the flights 133 and 134? Thanks.
Okay, I'll take the first part, and Mike will take the second. If we had to do a rollback, if we were informed through our instrument tanking test or our stress analysis that we had an issue where we felt like we had to get X-rays on the backside of the tank, we would do that. The preliminary look at a schedule would still support a February 3rd launch.
And as far as 133 in front of 134, because of the interaction with the HTV, we would like to fly 133 before 134 flies. In addition to that, 133 has a number of these tanks I referred to for the urine processing assembly. And so we'd like to have a set of those on orbit so we quit disposing of urine and instead process it back into water. So for those reasons, we'd like to keep 133 in front of 134.
Okay, thanks, Ken. Let's see, Gail Putrich, are you out there with Flight International?
I am. I guess most of the window questions have been answered. I guess what I'm really wondering is how long can this keep pushing?
You were kind of breaking up, Gail. Can you repeat that?
Sure. How long is NASA really able to keep pushing this back? I mean, you mentioned dates as far out as April or May. Is that like something you're seriously considering might happen?
Well, what I would say, and Bill Gerstenmaier may want to chime in on this one, is that our focus right now is on STS-133 and Discovery and solving the technical issue and launching in February. Looking downstream, it does not take us significantly further past where we were prepared to launch a 335 rescue mission. That was in June anyway. So the end time for our last mission really hasn't changed. But if we stumble on something that causes us to rethink what we would need to do with the external tank, then we'll go back and look at the overall schedule. I don't know, Bill, did you have any comments to that?
Yeah, I guess, John, I'd just kind of echo exactly what you said, that we need to focus on 133 as we are. We'll take the time to understand the problem, and we'll get ready to go fly when it fits. We can address all the other what-if stuffs and see where we are, but we've got some margin in the remaining time frame. We can get the job done, and things will fit from an overall flight standpoint. So I think right now the real job for us is to not worry too much about the overall schedule. We've got a good plan, as Mike laid out, from being able to support station, and that's our ultimate goal, is to leave station in the best configuration we can, and that's laid out well. We'll figure out a right way to get this understood, and then we'll take the data as it comes to us. We'll figure out what to do with it, and we'll move forward. But I think they've laid out a very sound plan that gives us plenty of margin, and we're not constrained overall from a mission standpoint and the way it falls and moves forward. So I think the thing for all of us to remember is we really want to make sure this flight is successful. We really need the cargo to space station. The best way to do that is do what the teams are exactly doing right now, is to do the testing that needs to be done, to get the analysis done the proper way, and get ready to go fly when it's time to go fly.
Okay, back to the phone bridge, or Bobby Block with the Orlando Sentinel. Bobby?
Hey, I guess this is for Bill. And then there's a quick follow-up that I have for John. But the first one is, if 134 was supposed to go in February, how does moving this flight to February impact 134? And what budget impact is this going to have on the program? And will that impact the budget requirements for 135?
Again, where we're thinking right now is we would move 133 to the February 3rd window that opens up there. Then 134 would fly around April 1st, and then that flight completes about the middle of April. So if you looked at where we were before, 134 was on the 28th of February or so. Now it's moved a couple days, or I guess it's moved a little bit into the April time frame. And I think we have sufficient margin to go ahead and go work all those activities from a budget standpoint. So we haven't really pushed or upset anything from an overall budget standpoint.
Go ahead, Bobby. You said you had a follow-up.
If previous tanks may have been seeing these similar problems and they just haven't missed? I mean, have we been flying with cracks before, or is that still an unknown?
That's a good question. As part of our data mining, think about what we have done. I'll give you two parts to this. The first is, after we did the cryoloading, we saw the initial crack, and we excavated the foam, saw the other crack on the stringer right next to us that may be related. We did the X-ray of all the other stringers on the orbiter side of the vehicle that had just seen the cryoloading, and it is very high fidelity X-rays. We are able to see down to very small details, and there is nothing there. There are no cracks. We took the same system over to the VAB and did the X-rays on ET-138 and ET-122, and they have not been cryo-loaded, but we couldn't find any flaws or any fractures or anything at all in those areas, and that's all the way around the tank. So, you know, the other piece of it that you have to understand the limitations of it is the flight history piece of it. We have excellent views of the LOX intertank flange pre-launch after we load it up and we're sitting there, and either through the television cameras or the final inspection team going out there, we would clearly have seen if we had a crack up in that LOX flange area, and we never have. Now, there's a more subtle question here. Could you have had a smaller crack that would not have displaced the foam that you were launching with, that you wouldn't have seen in that final inspection team review? I don't know the answer to that. What I can say, though, is that our assessment of all of the imagery that we have had, and we've spent the week going through it, the LOX intertank flange has never lost a significant piece of foam. You've had some erosion or maybe some popcorn in that area. We have never lost anything. That's not a surprise because it's not susceptible to the cryo pumping that you get down on the hydrogen tank flange area, where we have lost some foam, and we've taken some significant actions to mitigate that. But up on the LO2 flange, we've reviewed and we haven't lost any significant pieces of foam. We've also looked very hard to see if we had any cracks, just to see if you had a crack that was in the foam that did not liberate the foam. That's a lot harder to do. It depends on the lighting angle. It depends on the focus of the camera and stuff. So there are limitations to that, but we have not seen any cracks from the imagery that we have so far. So this was a unique event to us, and I don't have any data that says that we've been flying with cracks all along. There's some limitations to that because it's a secondary look through foam displacement as to whether you had a crack. But I know on the tank that I have out at the pad right now on the orbiter side, those 54 stringers, I have no other cracks. So I'm sharing the data with you, and you can draw your own conclusions. There's limitations to that data, but I also don't have anything that indicates that this is a generic kind of problem.
Okay, let's see. Next up is Adam Mann. Are you there, Adam?
Yeah. Hi. I guess this would be a question for Mike or John. Is there any discussion, you said that both of the flights are full, 133 and 134. Is there any discussion that the alpha magnetic spectrometer, which was meant to go up in February, would go up on 133 instead?
No, that would be a significant impact to rearrange the cargo bay at this point. So that's not something we would entertain. Really, the objective is to fly these flights as we had planned. We have no reason to change the plan. The AMS is processing well, and they don't have a constraint to waiting a little bit longer to go fly. And so right now the arrangement we have today works well for all the folks involved, and it would be a much bigger impact overall to the program to try to rearrange the payload bay, and you certainly couldn't do that in the next few months. It takes much longer than that. So the fastest way to fly these flights is to fly them in the order that we've got them today.
Okay, two more folks before we close the briefing. Todd Halverson, Florida Today.
Yeah, thanks very much. I have one for Gerst and maybe one for John. It's kind of a two-parter. I wonder if you could give us an idea of the crew's reaction to the slip to February. And for Gerst, there seems to have been a sense that a slip into the new year might impact your ability to get the authorization you need to fly 135. And I'm wondering if you think that this will have any impact on your ability to convince Congress to go ahead with that one additional flight. Thanks.
I'll take the first part. We talked to Steve Lindsay, the commander of STS-133, right after the PRCB yesterday. Of course, the astronaut office has been very closely involved with this investigation. They were very supportive, understood exactly where we're headed, and Steve's only comment to me is that when the vehicle's ready, the crew will be ready.
And your question about STS-135 and the potential budget impacts of all these things moving, does it help or hurt our chances of getting 135? You know, I don't really think it changes it much one way or the other. Again, you know, our commitment has been to stay focused on these flights and fly them safely and do what it takes to really make sure they're ready to go fly. And, you know, I said in a couple of flight readiness reviews back that we would treat each one of these flights just like they were a regular flight in the sequence, and we would work all issues with the same rigor that we would, even though there's only a couple of flights left. And the teams have done that. We're doing that exactly here. So we are doing exactly the things that we talked about and laid out in terms of troubleshooting and working things forward. And I look to our congressional friends and the folks here in Washington to have that same respect for what we're doing, that we're honoring our commitment to treat each one of these flights as a true safety of flight issue, to make sure we resolve these issues, move things forward, and I look to them to give us the same consideration from a budget standpoint, and I'm sure they will. So I don't see any concerns about this. We're focused on getting the vehicle ready to go fly, keeping International Space Station resupplied so we can do really quality research there, and we'll move forward as we need to going forward, and I don't see an impact one way or the other from a budget standpoint.
Okay, thanks, Todd. Let's see, our last person on the line should be Irene Klotz with Reuters. Irene, are you there?
Thanks, Kyle. Yes, and I also have a follow-on question for Bill Gerstenmaier. Although you're saying that you don't think this delaying the launch till next year might impact the request for the 135 flight, but in the meantime, of course, things have changed, and another continuing resolution looks like it's on the plate, and there's a budget overrun on James Webb, and I guess I'm just trying to get a sense of the prioritization and where the 135 flight falls in the scheme of things. And then as a kind of a sidebar to that, if you had any thoughts on whether a successful COTS-1 demo by SpaceX next week will alleviate some of the concerns and the need for that year's worth of supplies that you were planning on the 135 flight. Thank you.
Okay, thanks, Irene. You know, I would first of all, again, say from a budget standpoint, I think the need for the flight is still as strong as it's been before. And what we've talked about for this flight is we really want to get those critical supplies to station so we can ensure that we get good research done on station, and we provide a little margin for the commercial resupply cargo flights that are coming online here with the flight next week. So I don't think the requirement for this STS-135 flight has changed at all technically. You can see from our discussions about what order we fly the flights in, what cargo is on the flights, how Mike describes the activities that he needs to do on station to keep the station resupplied and operational, how really tight this entire sequence is. And 135 is really critical to making sure we have robustness and margin to the schedule. So then to kind of answer your second part of the question, does a successful flight or a problem next week really change the need for 135? I'm not sure that it really changes that need much. What we're really looking for from 135 is some margin. You know, we want to, this is a unique opportunity for us to get supplies to station, and that can protect for a variety of problems that can occur later in the development process for the commercial cargo flights. You know, even though they have a successful flight next week, they will not have demonstrated a rendezvous and docking to station, a rendezvous and berthing to station. That's a very tough activity, as we've seen from ATV and HTV. So there's tons of challenges that occur in a developmental program or even in space flight in general. So even though they have a very good flight next week, which we fully expect them to do, we need to be very mindful that they still have a lot of work in front of them on their plate, and to have some additional margin provided by STS-135 to have some assurance that if they're a little bit late, they need a little more time to work a problem, they have the margin on station to go ahead and do that, and it doesn't impact research on station. So my bottom line kind of is, I think STS-135 is extremely important to us. It adds critical margin where we can. We'll have to balance that against the budget needs that the overall nation faces and NASA faces. We'll have to make those trades amongst them. It won't be an easy trade, but the technical reason for 135 sits there in my mind. It stays strong, and it's not diminished by what happens next week in terms of test flights, because there's still a lot of work that can happen. You know, we thought we were going to launch this shuttle flight. We had no idea we were going to get this unique crack phenomena and slip the shuttle as much as we did. The same kind of events can occur on the commercial side. They're not immune to any of the problems that we face all the time. In fact, they'll see the same problems as they do spaceflight. And to have the margin afforded by STS-135 could be absolutely critical to doing really good research on board Space Station.
Okay, well, let's see. I'd like to thank everybody for participating today. A couple of quick programming notes associated with that SpaceX launch next week that Mr. Gerstenmaier mentioned, that there is a pre-launch news conference at 1:30 in the afternoon Eastern Time Monday for that launch, and the launch coverage for the SpaceX launch is scheduled to begin about 5 minutes before the opening of about a 3.5-hour long window that starts at 9 a.m. or so on Tuesday morning. So tune into NASA TV. We'll cover both of those events, and there will be a post-launch and post-recovery of the Dragon spacecraft news conference as well. So stay tuned for those events on Monday and Tuesday next week. Thanks everybody for coming, and you guys have a great weekend.